Hello and welcome to today's event, Network Intelligence for Reliable School Wi-Fi. My name is Kevin and I'll be in the background answering any WebEx technical questions you may have. If you experience technical difficulty during this event, please submit your issue in the Q&A panel on the bottom right of your screen. You may also contact WebEx technical support at 866-779-3239. Please note that as an attendee, you are part of our larger audience, though due to privacy concerns, the list of attendees will not be displayed. We will be holding a Q&A session at the end of today's presentation, and you may ask a question at any time by entering it into the Q&A panel. As a reminder, today's call is being recorded. I would like to now introduce your first speaker today, the moderator, Jennifer Heisem. Jen, you now have the floor.
Thank you. Good afternoon, everyone. I'm Jennifer Heisem, an editor for LRP Publications and one of the program chairs for the National Future of Education Technology Conference. It's my pleasure today to introduce you to our speaker, Robin Jellum. But before I introduce Robin, I want to recognize Mojo Networks for sponsoring today's event. Mojo is revolutionizing Wi-Fi through the power of the cloud and open standards. They liberate networks from proprietary hardware and utilize the full power of the cloud to deliver cognitive Wi-Fi, a self-driving network that makes things remarkably simple and reliable at massive scale. Mojo Network's innovations empower IT with better use, better user experiences, more options, and more velocity, all at much lower costs. So thank you so much for sponsoring our event today. Also, I want to let everyone know that an archived version of this presentation will be available online on the webinars tab of fetc.org. Today's webinar is an excellent example of the education you'll receive at the National Future of Education Technology Conference coming up next week in beautiful Orlando, Florida. Okay, I think we're ready. So your speaker today is Robin Jellum. He's the Director of Technical Marketing for Mojo Networks. As Director, Robin develops and delivers technical training for WLAN professionals globally. Robin has worked in the local area networking and wireless LAN for over 20 years, holding positions in engineering, marketing, and support. He's a frequent speaker and blogger on wireless networking trends. I'll turn it over to you now, Robin.
Great. Thank you, Jennifer, and thank you, Kevin. Thanks for this opportunity. I really like to thank FETC for giving us this opportunity. What I'm going to talk about today is just some background trends on what's going on in the schools. I'm sure most of the attendees already know this. And then what you should be looking for reliable Wi-Fi and what's going on within the industry in general for networking. So the first thing we're going to do is have a survey just so I can get some background information on our attendees. What is your biggest challenge in creating a reliable network? Is it time? Is it money? Is it knowledge? Is it dated equipment? Is it inadequate tools? Please, we're going to have a little bit of time here to go through this session, and in the meantime, I'll be giving a little background of what's going on. So right now we're seeing networks being used more than ever. We see all sorts of networks all over the world. We see cellular networks, we see home networks. Wi-Fi is certainly a part of that. And the trend is for everything to become more easy to use. So, for example, in the home, we have TVs that are connected to the network. We have streaming devices like Apple TV or Chromecast or TiVo. We have DVD and Blu-ray players that stream content. And then, of course, we have laptops and tablets and phones and watches and, toasters and refrigerators, and all of these things now are connected to the network. So our network is becoming more and more essential to our everyday life. And one of the key things about that is that Wi-Fi is really enabling those technologies. It's not just the network. The network is certainly key, and the internet is certainly key, but the next extension of that is Wi-Fi. This is extended not just in the home, but also into offices. We're starting to see all wireless offices now where they're not pulling Ethernet cables anymore. Many laptops don't even have an Ethernet cable today. In the environment, we're seeing conference rooms with screencasting, so people can share their screen on a TV on the wall rather than an overhead projector, or even to an overhead projector. We're seeing many business collaboration tools which require both local network and internet connection, and then Wi-Fi is the local piece of that. And then certainly in schools, this is becoming key. There's been initiatives in the schools to bring internet to the schools. But the next logical extension of that is, okay, the internet's not much good if you can't connect to the internet. So Wi-Fi is becoming key to that. And Wi-Fi is not new in schools, but we're seeing is more and more people are adopting it. And what's happened in the last 3 years or so, you may have a dated Wi-Fi network which is causing you problems and isn't keeping up with what today's trends are in client devices. All right, so we see the poll. The poll has ended, and it looks like most people are saying money is the key. So 45% of the people said that money is the biggest challenge in creating a reliable network. And next to that is inadequate tools. So I'm going to be addressing some of these topics today and what we need to do to make a reliable network. So what we're seeing in schools and in the world in general is we're seeing a digital shift. We're seeing the trends of everything becoming digital, and that means you've got your laptop or your phone or whatever connecting to the internet, connecting to a network, connecting to each other to do things. So in K through 12, what we're seeing really is flipped classrooms. People are doing more stuff at home and then coming to school to do collaboration. We're seeing tools that are personalizing learning rather than teaching all students at the same level at the same time. We can personalize school plans, and there are applications in the background to help do that. And all of this is really try to make learning more hands-on, to be more like the business world where things are collaborative. You have to do things together. You can do online learning on your own. You can do things at your own pace. You can, with the internet and the availability of all the content out there, there's tons of stuff you can do for research. And this makes the whole learning process much more interactive and active, which more sticky with students. What we're seeing in schools, many schools, if they have the luxury of doing it, are going to a one-to-one model where they're having one device per student and assigning devices to students so they can use them throughout their school life. And then another major trend is digital testing, where they're doing everything on devices to do a standardized testing over Wi-Fi. And then in the schools, those are kind of the trends. But in the schools, we're seeing the other side of that, the devices that people are using. There are smart whiteboards, there are TVs, there's, we're getting more and more rich content like HD videos from the internet. We're starting to see augmented reality and virtual reality machines, which are connected over Wi-Fi. The user part of that is these very intelligent devices like iPads, like Chromebooks, and then the collaboration tools like G Suite. And G Suite's, a great tool for schools because it's free for schools. So, going back into that cost theme, this is a real valuable resource for schools. But Wi-Fi is really fundamental. The Wi-Fi part of this is the hardest part. Networks are difficult. Wi-Fi is really hard. It's really complicated, but it doesn't really have to be. We've done a lot of stuff in the recent years to simplify it, and Mojo especially has been doing a lot of stuff to make it very easy for users to use. So some of the challenges we see are, basic Wi-Fi challenges that you see everywhere. Coverage. When there's a problem, typically when there's a coverage problem, people would blame it on Wi-Fi. Well, it is a Wi-Fi problem. There's just not enough access points, so the access points aren't transmitting at a high enough power level, or it's just not fast enough. If you want to watch a 4K HD stream on your local device, you need a lot of speed to do that. You have to have a sufficient amount of speed to be able to see the high resolution of that. But the other side of that is, it's a challenge to manage. You want to make keeping the network up and running takes a lot of resources and takes a lot of time and it takes some training. Similarly, doing troubleshooting. Troubleshooting is where my background is. I spend a lot of time going on networks and troubleshooting networks and finding out, trying to reproduce a problem, which just takes tons and tons of time and knowledge and tools and experience. And then obviously you want to have something that's easy to maintain, and you need a secure environment. Schools especially, you want to have a very secure network. The other part of the challenges are BYOD devices. People are bringing their own devices. You don't know what those devices are. You don't know what drivers they have. You don't know what operating system they have. You don't know how they connect. There's some real problematic challenges there for the IT person. It may be a high-power device, maybe a low-power device. That can create coverage problems. If it's a low-power device, even though the coverage could be adequate for other things, it may be not adequate for that individual device. Because there are new things coming on all the time, new Chromebooks and new iPads have new technology in them. These are new protocols, and what you had 3 years ago for your network may not be sufficient for these new devices today. And then there's just all the operational stuff. When Apple comes out with a new iOS, there's a new driver in there, and that may have some unexplained consequences when connected to the network. And those are all built into the OS versions, and the OS versions have different interfaces. So all of this creates a challenge for the IT department to try to keep things running smoothly and reliably. The other trend is that IT resources really do remain the same. The IT teams tend to be static. The budgets tend to go down or become static. But with all these demands going on, you have what becomes a resources gap. You have all these additional things that need to be done to create a really good Wi-Fi network. But you have limited resources to do that. So you have this resources gap. And one of the things I'm going to talk about is how we can help fill that resources gap, or which you should not just Mojo, but what you should be looking for to help fill that resources gap. So the approach I'm going to take is that Wi-Fi really should be seen as a utility. Users expect a Wi-Fi network to be there. They, especially with more and more reliance with the trends going on in the digital transformation, users want to be able to use their device where they want it, when they want it. They don't want to have to wait. They don't want to have any glitches in it. They don't care who else is on it. They expect it to work all the time. This is very similar to classic utilities like your telephone. The old landline telephones, you always be expected to be able to pick up the telephone and speak and dial a number and be able to speak. Or your lights, when you come into the room and you flip a light switch, you expect the lights to come on. You don't even think about it. It's just second nature to you. Or water. We take all of these things just for granted because they're always reliable, or 99.999% of the time they're reliable. So when you turn on the faucet, water comes out of the tap. These are what we expect a Wi-Fi network to be, and we're building tools and technology in the chipsets and in the software and in the management systems to make this more reliable. On the flip side of that, what the IT departments really should expect from a Wi-Fi network is to have a minimal number of IT calls. The Wi-Fi should be able to, if not solve the problem itself, narrow down the problem very quickly so the IT person can resolve it quickly and without a lot of tools and without a lot of knowledge. Classic IT, they'll go in the back door and they'll go straight to the IT room because they don't want to walk down the hall because they're going to have somebody come up and say, hey, there's something wrong with my Wi-Fi. Well, you shouldn't have to do that. You shouldn't have to hide from your customers. You should be able to have a frank conversation and have the network solve its own problems. When there are problems, because there are going to be problems because of some of the challenges, but you should be able to resolve those very quickly. The network should aid you in resolving those if it can't solve the problems itself. And a lot of the management of the Wi-Fi network should be able to manage itself. You shouldn't have to do a lot of day-to-day management of the system. It should be really there. So all of this is really to say that Wi-Fi should be treated as a utility, should act as a utility, which means it's really got to be reliable. The challenge with reliability is it's not easy. I'm going to look at this in two different perspectives. So reliability really means being able to do the right preparation work. You need to make sure, especially in Wi-Fi, you need to do a lot of planning. You have to know where access points should be. You have to have the right kind of power to that, either PoE or local power. You have to do the right design for not just the applications you have today, but you have to think about what applications are going to be there in 3 to 5 years. So you have to do a lot of forward thinking and thinking about bandwidth and needs and applications and protocols and all of that stuff. once you've designed it and deployed it, then you have to do a validation of it. You have to make sure your design is what you expect it to be and acts as you expect it to act. Some of that means you're going to have some redundancy built in, so you don't have a single point of failure, or if you do have a failure, the other pieces of the network can adapt and fill in the gaps for that. All of this really means you have to have a very solid firmware and hardware base. So what we've seen in the Wi-Fi industry right now is that for enterprise class access points, they're actually very reliable these days. It's rare that they go bad. They do go bad, but it's rare that they go bad. They're all pretty much on par for performance. There's not a huge difference between them. So if you go with a reputable company with a decent quality access point, you're going to get about the same performance regardless of what. So the hardware is really not the differentiator. The hardware in access points, there's really only a couple of chipset vendors, and all AP vendors use essentially the same chipset. So there's not a lot of differentiation on the hardware. What's different is in the software. So I'm kind of, and that's where making the operational side of this makes a little bit of difference. On the operational sides, for keeping things reliable, you have to know what your network's doing. You have to keep up with what the trends are. You have to keep up with what the vehicles are, the iPads and the software and all of those things and the protocols. So that takes a lot of training, and that's actually a very challenging thing to do, because that is some forward-looking operational thinking. You need to invest in training to be able to avoid problems, to make your network more reliably. The other side of that is, whichever vendor you pick for your Wi-Fi network, you have to have a reliable support structure, because when you do have problems, and if you don't have the right knowledge and the right tools, you need a Wi-Fi vendor that can help support you and come up with the right answers and quickly resolve problems as they come up. And if it's a bug in the system, and to be honest, everybody's going to have bugs, you want a vendor that is going to turn around and solve those bugs in very short order. You don't want to have to wait months to get a fix for a bug that's causing you some real pain. The tools are actually really pretty key also. So again, I'm a Wi-Fi engineer from way back. I used to go out on site, and I'd have a whole tool bag of tools, from spectrum analyzers and sniffers and all sorts of devices. And it took me years and years to understand the tools well enough to use them, and the protocols and how to use them. So it spent a lot of time getting the tools working, making sure these tools work appropriately. A lot of that can be built into the Wi-Fi systems. A lot of stuff that I've used in the past is now built into Wi-Fi systems. So in many respects, what I did in the past is going away, which is a great thing, because I used to go on site and walk around for days trying to reproduce a problem. I don't have to do that anymore. The system can find the problem for me and notify me of the problem, and potentially solve the problem before. The other thing that's really key to operational is that you want to be able to make sure you have the latest code on your network. Bugs are always in the code, and fixes are always coming up, and new features are always coming out. You want to make sure you have the latest and greatest on your networks, because that will help minimize your operational costs, that will help minimize your problems, and that will make your network more reliable. So what's really important? Well, what you want to do is, for a lot of this stuff, is you want to make the network more proactive. You want to increase the amount of proactive work and decrease the amount of reactive work, because the proactive work is the planning, the reliability, the things that you can look at and make a plan for. The reactive stuff is the stuff that takes you away from your essential duties. If somebody's got a problem, you're going to have to react to that problem. So if you can avoid the problem altogether, that saves you time, that saves you money, that saves you consternation. So back to the making things reliable, you want to do the planning, the validation, the testing, the monitoring, all of that stuff is proactive activities. What you really want to reduce is the amount of time it takes to find problems. And a lot of times people won't even report a problem. They'll just live with a problem over and over again, and eventually when they see you in the hall, they'll say, hey, there's a problem. Well, that doesn't help solve the problem. That just causes consternation on the user side, and it doesn't help the IT staff get to a place where they have a reliable network. So the key to this, to helping decrease the reactive problems, is to really give the best information possible to troubleshoot the problem in the quickest time as possible and with the best support as possible. So some of that is making sure that you're local to the problem. If somebody reports a problem in a building, a mile away, that's time you have to go and travel and try to troubleshoot the problem. So if you had a tool that could help troubleshoot that problem in that location without travel, that would be a great thing. Some of these problems takes a fair amount of knowledge. So again, if the system can help you build that knowledge in, so you don't have to have all of it in your head, you can apply it as it appears. That would be an awesome thing. And the other thing, building all the tools into the system, so you don't have to have this bag of tools and go on site to do the troubleshooting. All of that could be built into the system, and that could help reduce the reactivity, or at least reduce the amount of time it takes to get to the point where you could react to a problem. Okay, so now we have a second survey. What is the biggest pain point an intelligent network can help with? Is it optimizing the user experience, diagnosing and correcting problems, validating the network before a big event, keeping the network safe, or just everything? So, as I said before, networking isn't easy, and Wi-Fi is especially difficult. The smart network devices are leading. The applications and the devices are all leading the technology, and Wi-Fi tends to lag. And so what you need is you need to make sure that you buy a Wi-Fi system that can respond well and be upgradable without a lot of pain. The more intelligent the network, the less work the IT has to do, because the network can solve problems for you. That's the goal. The nirvana of it is to have a very intelligent network that solves problems for you and just reports to you what the event was. Even better would be to see problems before they occur, not before they become a problem. See a trend, and then respond to that trend in a way that solves the problem before it ever actually impacts users. Great. So the responses are, 38% of the people said they really want to optimize user experience, which is great. That's really what Wi-Fi is all about, is trying to make things easy, make it a utility, make it so you don't even think about Wi-Fi. Wi-Fi, if it works perfectly, you don't even know it's there. The second most response was everything, I need a break. So 29% of the people are just overworked. Perfect. That's why we're here. Let's see how we can help you move on. So what intelligent networks should do is bridge the gap. And what bridging the gap really means is you've got all these things you have to do, all these demands on your time with the same amount of resources or fewer resources. So what you really want to do, what you want the network to do, is to simplify. You want to simplify all the stuff that the network does. You want to automate as much as possible, let the network do things for you. And then key to this really is innovation. You want to be able to have an innovative network that you can add more innovation to over time that does the simplifications in these automations. I'm going to go through some of these things in the terms of configuration, performance management, troubleshooting, and security and maintenance. So to kind of see what you need, what you should expect from a vendor for these types of networks. So really what simplify, if you do all of these things, if you can bridge that gap, that makes a more reliable network. So simplifying really means, you want the system to be easy. You want to have, and it boils down to a few things. You need a user interface that's easy to use. You don't want to have to learn a new system. You don't want to have to learn 4 systems. You want to be able to have one single user interface where you can go and manage everything. It needs to be easy to use. It needs to be designed by user experience people who have gone through workflows to make sure that the less knowledgeable people can be able to use it effectively. You don't want to have a CCIE be able to configure and troubleshoot a network. You shouldn't have to do that. We have enough knowledge, and we can build enough knowledge in the system that you can make a less educated, less knowledgeable person troubleshoot and set up a network and make it still reliable. You want a system that will simplify your life by diagnosing the problems on its own. A lot of the Wi-Fi problems are well-known problems. the access point can see things that is happening. It should be able to recognize those and report exactly what the problem was, and save the IT person a lot of time in collecting data to try to figure out. The network knows what the issue is. It should just report what the issue is and hopefully solve that issue if possible. The other thing is, this kind of gets back to usability, is like, with Wi-Fi systems and networks in general, there's so much data. We're gathering so many pieces of information that it gets lost. You get lost. You go look at these interfaces, and there's just so much stuff there. You don't know what's important. And to find what's important, you have to have a lot of knowledge and have to do a lot of hunting and pecking. So a well-designed system will show you what's important. Will give you the most important thing right in your face that you can go deal with that. And if you want to go get other information, you can. But you really, when there's a problem occurring, that's the most important thing. I want to see that problem occurring. I want the system to tell me, here's a problem and here's the answer. And then back to the usability, you want to make sure that the system works as people want to use it, not as it was designed by some network engineer 20 years ago, right? The system should be, we're so used to devices now being very easy to use because usability experts have risen in the industry. So now things are very intuitive because people spend a lot of time designing and testing how do things work. So that same should be applied to network interfaces. So you should be able to figure out how to create a system and troubleshoot a system without having a lot of training. The automation side really is about how do we make everything easy, right? So setup, AP setup, you should be able to plug in an AP and it should just start working. It should be that simple. The APs should do some coordination between themselves. They should figure out what the best channel is so they're not overlapping with each other. They should figure out what the right transmit power is. So you don't have coverage holes. You shouldn't have APs that are really, really high power and some really low power. Ideally, what you want is an AP who's matching the transmit power to the client device. This is called power transmit symmetry. You want to have symmetry between the client device and the AP, but you also want to make sure you have coverage. So there's some strategies there to be able to do that. The system should do this automatically. You shouldn't have to figure out channels. You shouldn't have to figure out transmit power. The AP should figure this out and let you know what's going on, and then should validate this. Are these the right transmit powers? Are these the right channels? If something occurs in the environment, if a microwave goes on or if there's some sort of an interference, the network should react immediately and still provide a great user experience. Some of the other automations, like the troubleshooting, when a problem occurs, the system can recognize a problem. It should automatically do a packet capture. You shouldn't have to take a sniffer out and try to reproduce a problem. The system knows there's a problem. It should do a packet capture, and it should do a root cause analysis at the same time. So you shouldn't have to do any of that stuff. The system should be able to do that for you. And then on the innovation side, it's hard to future-proof, but what you want to do to future-proof is make sure you have a scalable architecture that can handle additional features. So, for example, you want to have an access point that is intelligent. You want to have enough processing power and memory on that access point that new features can be added without bogging down performance. A lot of the stuff that needs to be done is done based on huge amounts of data. So to be able to detect trends, you need a lot of data and data science to be able to munge that data to figure out what the challenges are. To do that, you really need some horsepower. You need a large data storage, and you need a lot of computing power, and that really comes down to to doing things in the cloud. The cloud has massive resources in it, much more than you could ever put on a local site. And by leveraging the power of the cloud, you could look at trends not just across one school, but across multiple schools. You could put all that data together very securely to see if there are trends happening and trying to come up with a strategy to solve a problem that doesn't quite exist. You can only do that by having massive data sets, and you can only do that by using the power of the cloud. With that massive data set, you can do things like artificial intelligence and machine learning. So you have a system that's learning on its own and is making some intelligent decisions and ferreting out problems before they occur. All of that really comes down to you need some sort of self-awareness. The access point should know when there's a problem. It should detect that problem. It should report on that. It should try to counteract that problem. It should do all that real time. It shouldn't need some back-end system telling you what to do. The back-end system is really about gathering the data and looking for trends and looking for problems and trying to see things that you can't see on a small data set. That's what the cloud is really for. The access point itself should be very powerful and intelligent in its own right to do the things it needs to do quickly and locally. And all of that really comes down to cognitive Wi-Fi. That really is saying we want a Wi-Fi system that is smart. And smart means smart APs and the cloud that works together to come up with some very creative and smart solutions. So now jumping a little bit more details on the individual components. Configuration, I kind of talked about this. Configuration, you should be able to set up an access point. You should be able to set up an SSID in minutes. It shouldn't take you hours. It should take you just a few minutes. You should be able to do it in a few steps. There are tons and tons and tons of options that you may want to apply. They're not all relevant. You should make it simple for the most common network. And it should really be trivial. Actually, you shouldn't have to think about it. For configuration, you really want to have it cloud managed also, because you want to be able to apply a configuration across multiple places. So having a hierarchy of locations and being able to create a configuration in one location and apply to all locations would just simplify life immensely. And then being able to modify things on a local level could be done, but you want to be able to manage it simply from a single user interface. You should be able to apply a configuration to an AP anywhere at any time, and that really gets back to the cloud. If you have things in the cloud, you can use a web interface and go and design things and change configurations, and that gets pushed down to the AP locally, no matter where that AP. It doesn't really matter. You don't have to go on site. You don't have to VPN into anything. The cloud just can handle all of that stuff. Secondly is, and these aren't in any particular order, these are all just important things, but performance is key, right? You want to have an access point and a network that can do the things you want it to do. So you need a very high performance access point, especially in the schools where you don't know what's coming, where you're starting to see 4 and 5K HD stream content. That takes a lot of horsepower and a lot of bandwidth in the air. So you need to make sure you have enough bandwidth for that. So 802.11 AC Wave 2 is actually really sufficient for many of the needs today. 11AX is coming out. It hasn't been standardized yet. It's supposed to start dropping some enterprise access points later this year, but it won't be adopted widely for a couple of years. AX gives you gigabit speeds. It's actually good enough for most of the applications today and tomorrow. But what you want to look for is an access point that is powerful enough. You need to have a 4x4 access point, because a 4x4 access point will give you lots of data streams, lots of bandwidth. With a Wave 2 access point, you can use multi-user MIMO, so multiple people can be talked to at the same time using the same access point. So that's key. And then, of course, having the access points in the right place. You want to make sure you have the right coverage, because the closer the users are to the access points, the more performance they're going to get, and the better experience they'll have. And then operationally, you need to keep that thing running properly. So the access points need to know if there's another access point in the air on the same channel, and it needs to move channel if it is, because when you have two access points on the same channel, you're essentially having the throughput. They're sharing the channel, so they don't each have as much as if they had their own channel. AP load, if you had some students on one access point, if you had 30 students on one access point and 5 students on another access point, the AP should be able to load balance those clients if their signal is good enough and the speed is good enough. All of this stuff should just be automatic. So what you really want to look for when you're looking for access points is a high-performance access point. You want to have a 4x4 access point. You want something that's making local RRM decisions. I say that because if the access point has to send data to some back-end system, and that back-end system has to make a decision and push it back down to the access point, that takes some amount of time. And if you have some reason you lose connectivity to that back-end system, the access point can't make a decision on its own. So you need access points that are going to make a local decision without a lot of back-end intervention. And you need to be able to have an access point that responds quickly. And so I'm doing a presentation later in February about why every access point should have a third radio. The third radio, a third non-access radio, is really, in my view, essential to an access point, because with that third radio, you can do security scanning, you can do RRM scanning, you can do sniffer traces, you can do spectrum analysis, you can do all of this without impacting the access of the students in the classroom. So if you had a problem, you could use a third radio to diagnose a problem remotely without taking that access point out of service. If you had an AP that didn't have a third radio, you'd have to take one of the radios out of service to do some of this stuff, or in some cases you might have to take the whole AP out of service. So what you really want to do is, again, trying to make things reliable and try to troubleshoot things as quickly as possible. In my opinion, a third radio is essential. And then, likewise, the RRM decisions has kind of declined in band steering. So for management, you see, hopefully you don't have to do a lot of management for this, but if you had an intelligent Wi-Fi system, you would even need to do less. So again, what you really want to look for is a single user interface. You don't want to have to go to multiple systems to manage your Wi-Fi. You want to be able to connect to it easily, and that, a lot of times that's from a web browser. So a single user interface on a web browser means you can connect to it from anywhere, anytime. So if you get a call, you're on vacation and something bad happened, you can, from your cell phone, connect to the network and actually do some configuration and management. You want a hierarchical management framework, so you can set a configuration at one level and management at one level and push that throughout the organization, and then make local changes as you need to. But for the most part, you want to keep things as simple and as streamlined as quick as possible. Any action you make at the top level of hierarchy should just automatically flow down through the hierarchy. And you may need a couple of different configurations so they can flow down through. You may have something for elementary schools and something for high schools that are slightly different, but you want to be able to set a policy at the top level and have it flow down to all the different things that are under that hierarchy. The UI really needs to be designed by usability experts. Easy to use, easy to understand, show you what's important, not show you tons and tons of stuff. Of course, it should show you tons and tons of stuff, but you don't want to have to go through all of that chaff to get to the important thing. It should be right up front and center. Here's the most important thing that's going on right now, and you need to do something with this, or I've already dealt with it. And then kind of back to the hierarchy, you need to be able to keep your access points up to date, and that means having a quick and easy firmware upgrade process. Some systems you have to take all the access points offline to be able to do an upgrade. Some systems you can be more granular. So with Mojo you can access one access point, you can upgrade one, you can upgrade some, you can upgrade all, you can do one school, you can do one classroom, you can do whatever. It's completely flexible. And I think that's kind of essential to easy management. And the other thing is, should an access point fail, because some of them will, you want to make the RMA process as simple as possible. The challenge with I used to work in a support organization, and RMAs were always a pain point for customers, because dealing with shipping things back and tracking things down, you want to avoid all of that as much as possible. First of all, you do it by buying high-quality access points, but should one fail, you don't want to have to go through all the hassles of dealing with an RMA, so you want to have a very simple RMA policy. And then troubleshooting. I think this is where, again, this is kind of where my background lies, so this is where I'm really passionate about. For troubleshooting, what you really need to look for is an access point that can do intelligent root cause analysis real time. So when a problem occurs, you want it to be able to notice the problem, capture packets about the problem, do a root cause analysis of the problem, and send all of that data to the management interface so you can look at it, and send a notification saying, hey, here's the problem that occurred, and, oh, by the way, I solved it. Ideally, the access point should be able to solve the problem. You need to make sure, to do that, you need to make sure you have a lot of key performance indicators. So the network and the access point need to monitor a lot of different systems to look for trends and look for triggers. So you have to have all those implemented in the access point, and the access point has to be powerful and intelligent enough to be able to look at these, monitor these, and then react to these in real time. Another thing is, in my opinion, the access point should be the first line of defense, which means you want to have a firewall on the access point, and you want to have application visibility on the access point. So the access point should be able to identify an application. It should be able to do something with that application. If it's a unnecessary or an unwanted application, it should be able to do something with that. Likewise, it should just be able to track and see what kind of applications are being used, what time of day, how much data they're using, all of that stuff. Those are all kind of key metrics that need to be tracked. And for some applications like voice and video, you need to automatically detect it and provide quality of service for those, because voice and video need a higher quality of service. And you have a lot of data and voice and video on the same access point. You want to make sure that voice and video get through first with the best quality, because that's really user impacting. Whereas if you have to wait another few microseconds for some data to come through, it's not that big of a deal. But that's very noticeable on voice and video. Again, I talked about the third radio. For the third radio, you want it to be able to do RRM, interference detection, WIPS protection. All of that should be done on the third radio instead of an access radio. It should be able to do spectrum analysis. And ideally, it should be able to use that third radio as a client to connect to a neighboring access point. So if somebody reports a problem on an access point, rather than traveling there to do a test, put the third radio of a neighboring AP in a client mode, connect to that access point, do all the sorts of tests you would do if you were on site with a real client, and have that report back to you. That's nirvana. That would be ideal. If I had this when I was a network engineer, I would never have to travel on site. Similarly, to be able to do a lot of this data, use a lot of the higher data sciences, you need to have a big data mechanism. You need to have something in the cloud that can handle big data and can do artificial intelligence, do machine learning. You want an access point that can actually do real-time analysis of packet flows, so you can detect a video or a voice stream and evaluate how good that stream is real-time without impacting the data. These are all things that we should expect from intelligent networks. And then, of course, security. Security is hugely important. You don't want to discount that. To make security work well, you need to have something that's not just reliable, but accurate and fast, right? So with many WIPS systems, wireless intrusion prevention systems, detection and prevention systems, there's a lot of false positives. In fact, many Wi-Fi competitors will recommend turning off WIPS because of all the false positives. I don't know if you know, but there are laws on the books that you can't interfere with a neighboring network. And so some of these detection and prevention systems can actually interfere with neighboring systems, and that's a real big no-no. So they recommend turning off this. So you should use something that has a very, very high reliability of no false positives and no false negatives. It should use some advanced technology that will resolve these issues quickly and fast and reliably. So that's essentially in our terminology, that's marker packet technology. We have a unique way of doing this, which is unparalleled in the industry. And then also, if you're using Google for Education, you want to be able to integrate with Google for Education with your Wi-Fi system to take advantage of the organizational and the security of Google for Education, and add another layer on top of that. So it integrates with your Wi-Fi system and adds another layer of security. And I've been talking a lot about the cloud. I really believe things need to be in the cloud, but there's an extra added risk of having things in the cloud. So AWS, Amazon Web Services, is a popular cloud. They do a lot of stuff to keep things secure, as does Microsoft, as do all of them. Their data centers are highly secure. What's not secure, though, is what things get implemented in the cloud. So you need to do two parts of making the cloud secure. One is you need to use a secure cloud provider, but then you need to make sure all of your own processes are secure in the cloud. So what you really want to do is make sure that you have an SSAE-16 SOC2 compliance for both cloud and operational environments. This is really key, and Mojo, it started out as a security company. We strongly believe in security. We believe that if you're going to use a cloud, you should have a secure cloud. So in conclusion, Digital learning is increasing. Wi-Fi is mandatory, and it should be treated as utility. It should be rock solid. It should be intelligent. Resources are tight, so you really need to be able to have a smart network that makes things simpler, automatic, and innovative to fill the gap. So now I'm going to give a little plug about Mojo. So Mojo Networks has been around for a long time. We are innovative in many, many different ways. We have a lot of patents that are unique and innovative, but we're also coming up with a new model, which essentially we take zero profit on access points. The access points are sold at cost from us to the user. So this means we have actually a very low price point. But because the access points use the same chipsets made by the same manufacturers, they're extremely high quality, powerful, fast access points. We're just trying to change the market because we think that network vendors are taking too much profit off schools. So we've designed our cloud from the ground up to make it extremely reliable, extremely easy to use. We've hired usability experts, and we've gone through workflow, and we do usability testing on all of our stuff. So it's very easy to use, very easy to deploy. We have all of the network analytics. We were born in the cloud. We started in the cloud. We've gathered a lot of, because we started out as a Wi-Fi security company, we know all about the security, so we have the best-in-class security, but we also have a deep understanding of how Wi-Fi works, and we've gathered a lot of information to come up with some great analytics to be able to track things. And then based on those analytics, we can do things like machine learning and artificial intelligence to make things very easy to understand and troubleshoot. Because it's in the cloud and because everything can be managed in the cloud, we can add more applications, more intelligence easily to the cloud. And with our licensing model is once you buy a cloud license, you get all of our new innovations for free. There's no extra license. You don't have to pay separately for WIPs. You don't have to pay separately for analytics. You don't have to pay separately for guests. All of that's included. It's a very streamlined, simple model. So I'm not going to spend too much time on this. I've talked a lot about this, but everything I've been talking about, I think we do. We have a single user interface. We've done UX design. We have on our access points intelligence that can do root cause analysis. When you connect and you fail to connect to an access point, the access point understands that you failed. It does an automatic packet capture. It does a root cause analysis. It reports that to the cloud with the packet capture, and it'll tell you failed because you entered the wrong key. And if you want to go and see that, you can go look at the packets. All that's done automatically. Comes with the system. Our deployment is easy in the industry. You plug it in, and if it adopts the configuration that's for that location. Very, very simple. Our ordering is simple. Since we don't have any extra licensing, you say which AP you want to buy and how long you want to have a cloud service for. That's it. You don't have any extra license. You don't have anything else. And then the RMA process. We essentially have a no RMA process, which means if you have an access point go bad, you call our support, they validate it's bad, we'll send you a new access point. You don't have to return the other access point. You just have to verify that you destroyed it. So again, we're trying to make things as simple as and easy to use as possible. So kind of getting back to the automation theme, we have zero-touch config. You plug the AP in, it works. All the intelligence is on the access point, so it does power channel, band, client management, all on the access point. The access points actually communicate with each other, and they pass information with each other to make intelligent decisions. We do auto-packet capture. One of the key things that we do is that we are all API-driven, so everything we do has an API. So we have customers that don't even use our interface, even though we spend a lot of time on interface. They already have the system they want to use, so they do everything. They've written APIs to gather information and manage everything from their own interface. All that's to say that we can make things happen very quickly. We can solve problems very quickly. We can come up with new programs very quickly because everything is API driven. And then we are really an innovative company. We've done things like we've come up with Wi-Fi, cognitive Wi-Fi. We're doing things on the third radio. So third radios aren't necessarily unique in the industry. There's a number of AP manufacturers that have the third radio that do some of the things we do, but we take it to the next level. We are doing client testing. We're taking that third radio as a client and talking to neighbors and doing troubleshooting live. We can schedule those tests. So if you have a big meeting coming up and you want to make sure that everything is working, you can schedule a test to make sure that tests that access point at that time. We have the best in security. We are doing a lot of big data in things, and this next year we're going to see some really unique things come out with machine learning on artificial intelligence. We do great stuff on reporting things today, but we're going to take it to the next level in the near future about not just reporting on that, but actually fixing problems on its own, making it a smart network. The other thing that we're doing, again, we're trying to disrupt the industry, is we're part of an open standards community. So it's not quite there yet, but there will be an open AP that we can actually, you can buy it. At some point, you'll be able to buy an AP off the shelf, and you'll be able to manage it with Mojo software. It could be anybody's AP, so you can buy anybody's AP. We're not there yet. We're finding real pushback from our competitors on this because, to be honest, they make a lot of money on their APs, and they don't want to lose that revenue stream and the service stream. So this is something we're pushing hard because we think open networks and open source is the way to go. We are a founding member. We're going to be showing some really pretty cool stuff here in the next couple of weeks about what's going on. But with that, we can lower costs and we can give the customers more choice. All right, I talked much longer than I expected to. I apologize for that. Shall we open it up for Q&A?
Hi, thank you, Robin. That was great. Yes, just as a reminder, you can send a question to us through the Q&A box on your screen. Robin, we actually had a couple questions come in while you were talking, so I'm going to get to those. Our first one, how exactly do you integrate with G Suite?
So with Google Suite, G Suite, Google for Education, you can actually use, if you manage your Chromebooks with G Suite, the MAC addresses will be sent over to us, and it's another added security level. And based on your organizational units in Google for Education, those will also get transmitted over to the Mojo system, and rules will get applied. So you can actually have VLANs or prioritization based on the organizational unit set up in Google for Education. And it's a simple thing to do. Google for Education is actually the hard part, to just have all that stuff up. If you're already using that, you've done the hard part. You create an API link between what we call Mojo Enforce and Google for Education. Once that API link is up, you copy things over and you set up some simple rules, and you can do a lot of really powerful security and management stuff.
Okay, thank you. Our next question was, are the Mojo APs thin, as in run by a controller?
No, and they're not. And we don't want them to be. Again, my contention is that you need to have intelligence at the edge. The first line of defense is the access point, so you want to have that access point doing a lot of the intelligence things. If you have a thin AP, which means kind of the access point's doing half of the AP function and a controller's doing half of a function, you're actually then relying on a controller, and that controller may not be local. That may be somewhere else. So if you have a line go down, or if you have some interruption, the access point stops doing a lot of the functions. So we strongly believe in having intelligence at the edge, where the access point does a lot of the smarts, does the packet filtering, does the packet tracing, does the firewall, does the access, does collaboration between its neighbors because it knows its environment best, rather than having some back-end controller, which actually adds a lot of cost and complexity to the solution. Okay,
well, thank you. And we have another question here. What happens if the AP loses connection to the cloud?
The AP, because it's an intelligent AP, it completely keeps operating as it should. The only thing that happens when if the AP loses connectivity to the cloud, is some of the statistics will be gathered on the AP, and once the connection's back up, those statistics will be delivered to the cloud. If there's a configuration change made while that link is down in the cloud, that won't be pushed to the AP. But the AP keeps operating completely and with complete functionality. The RRM functions keep working, the firewall keeps working, the root cause analysis keeps working. All of that keeps working until the cloud is restored.
Okay, great. And then we have another question. Do you have the ability to create red and green zones, or any other way to define areas where students can and cannot access social media apps? For example, I do not want students to have access to social media in classrooms.
Yeah, because we can do hierarchical management. We can actually management at an AP level or a group level. We can set up firewall rules, application rules for some areas and not other areas. So yeah, we can essentially allow social media in the cafeteria, but not in classrooms.
Okay, great. And then another question, do you have any support for single channel, i.e. all APs use the same channel?
We do not. We don't think that's the right way to go. I know there are some competitors that do that. The challenge with that, especially as you get to higher bandwidth applications like 11AC, is that you're sharing the channel amongst everybody. The theory is that you'll have a little bit more control and you can schedule things a little bit better. I've worked with these architectures in the past, and to be honest, it just never really panned out. It was always a challenge for me, especially with voice and video apps. So yeah, we don't believe that. We think Wi-Fi has multiple channels for a reason, and what we try to do is pick the best channel to use.
Okay. And another question coming in right now. Can Mojo system tell if an AP is having problems with interference from building materials, such as wire, metal, cement block walls?
Interesting question. So it won't tell if you have, that's going to be a transmit power thing. So what you can do is have one AP hear another AP. It will be able to detect the signal strength from the neighboring APs. And these APs talk to each other all the time and share information like client information, like power levels. There's a fairly sophisticated transmit power algorithm that, depending on how the AP sees other APs, it will power up, which will help counteract some of this attenuation from building materials such as concrete walls or steel or things like that.
Okay. And we only have a couple minutes left, so we have one last question, and then we'll close out. But why is a third radio important? I know you had mentioned it during the webinar, but maybe you could repeat that.
Yeah, sure. The third radio just allows the access point to continue doing what it's supposed to be doing, which is providing access to all the clients, while it's doing all of its other really important functions, like doing security, like doing RRM scans. If you need to do troubleshooting, you don't want to take an access point out of service, and ideally you don't have to travel to a site. So using a third radio, you can remotely troubleshoot an AP by connecting that third radio as a client to an AP. You can also do a spectrum analysis using the third radio on that AP, so you don't have to take it out of service. So the third radio is really key to keeping the access point acting as an access point, but still providing really key management and troubleshooting tools.
Okay, great. And we just have a couple more minutes. So, Robin, do you have any closing remarks before we sign off?
No. Well, I want to thank everybody for listening. This has been very enjoyable for me. I appreciate letting people listen to me talk about wireless. I love to do it. And then thank you for letting me talk about Mojo, because I'm really excited to work here, and I think we've got a really unique story in the industry.
Thank you. Thank you, Robin. And thank you to everyone at Mojo who played an important role in putting together this webinar. And thank you to all our attendees today. I hope everyone has a great day.